At this stage, we're getting into some practice problems in context, so I'm not going to go through them very slowly step by step. There should be enough information here that based on what you've seen so far, you should be able to work through the problem. So I recommend that you try this on your own and then just go through the video as a quick check to see that your answers match mine, or if you get stuck on something, to get yourself going again. For the first part, we have to calculate our sample statistic p-hat by taking the number of heads, 140, and dividing that by the number of total spins, 250. Our null parameter comes from the null hypothesis, so it's this value right here, and our standard error is given in the statement of the problem as 0.032. Going forward, we will find some ways to calculate standard error, but in this section, it will just be given to us explicitly. So we get a z-statistic of 1.875. So marking our sample statistic, our null parameter, and our z-score on this graph, note that this is a two-tail test, because if we back up and look at our alternative hypothesis, it was two-sided. It was this not equals instead of greater than or less than. And because this is a two-tail test, we need to find the areas of both tails and add them together, or find the area of one tail and double it. So we get a p-value of 0.06. This is what our picture would look like in StatKey using our z-score of 1.875 on the horizontal axis. And that gives us moderate evidence that the Belgian euro is not a fair coin, that it comes up heads different from half the time. Again, I recommend reading through this smoking and pregnancy example and trying to fill in all of the details on your own, only coming to the video if you need to check your work or if you get stuck on something. Going through our first few steps, the first thing we want to do is rewrite these hypotheses in terms of a difference of proportions so that we can more clearly see what that null value is. The null value is always a number. When our hypotheses are written as PS is less than PN and PS is equal to PN, there isn't a number there really. If we write it as a difference of proportions and compare it to a number, that number is 0, which is how we get our null value. So we get a null value of 0, which we then plug into this same formula for the z-statistic. We're calling this null value instead of null parameter simply because it represents a difference of two parameters now. So it's not technically a null parameter, singular parameter, but it's the same formula aside from that. So we get a z-statistic of negative 2.23. Note that the sample statistic we were given is negative because of the order of subtraction that was chosen, and that is consistent with our alternative hypothesis being that PS minus PN is less than 0. So coming to the second part of this, we mark our null value of 0 at the center, our sample statistic and z-score off to the side, because the z-score is what we use when we go into StatKey. And that gives us a p-value of 0.013. This was a left tail test because our alternative hypothesis was one-sided with a less than, indicating that it goes to the left. This p-value is small enough that we would call this evidence strong, not necessarily very strong, which would have to be below 0.01, but we do have strong evidence that the proportion of successful pregnancies is lower among women trying to conceive who smoke than those who do not smoke. We don't necessarily know from this that the smoking causes a loss in fertility because this was an observational study. We didn't randomly assign smoking, which of course would bring up some ethical problems if one were to try to conduct a study in that way. So we can't conclude a causal association here, but we can conclude that it does look like women who smoke are less likely to get pregnant when they are trying to conceive than women who do not smoke.